Hi everyone, good morning. In the previous class, we learned some trigonometric formulas. Dear children, today in this class, we will study inverse trigonometric functions. Dear students, you know that sin theta or cos theta or tan theta, cot theta, secant theta or cosecant theta are trigonometric ratios or trigonometric functions. If x is equal to sin y, x is equals to sin y, then y is equals to sin inverse x, sin inverse x. So here y is equal to sin inverse x is the inverse function of x is equal to sin y, and you must read this expression as sin inverse x. So you should read this expression as cos inverse x or cos inverse of x. Generally we will read it as cos inverse x, sin inverse x, tan inverse x and so on. If sin theta is equals to x, then what is theta? Theta is equal to sin inverse x, sin inverse x. Sin theta is equal to x, then theta is equals to sin inverse x. Here sin inverse x is the angle, sin inverse x is the angle that for which the sine ratio is satisfied. Sine ratio is satisfied. Then such values are called as principal value, principal value branch, principal value branch. Again, theta is equal to sin inverse x. So here sin inverse x, sin inverse x is an angle that for which the sine ratio is satisfied. Then such values are called as principal value branch, principal value branch. Dear students, here remember one thing. For example, if sin x is equal to y, whenever you bring any trigonometric or inverse trigonometric functions from LHS to RHS or RHS to LHS, inverse becomes trigonometric, trigonometric becomes inverse. Again, whenever you shift any trigonometric or inverse trigonometric ratio from one side to other side, that is LHS to RHS, then the trigonometric functions becomes inverse trigonometric function, inverse trigonometric function becomes trigonometric function. For example, so this is trigonometric ratio, that is sin x is equal to y. Therefore, what is x? It is angle. Therefore, x is equal to, now this becomes what? Inverse trigonometric ratio, that is sin inverse y, sin inverse y. Or, for example, if cos theta is equal to x, cos theta is equals to x, then what is theta? Theta is equal to cos inverse of x, cos inverse of x. Or for example, so that is y is equal to tan inverse x, tan inverse x. Then what is x? X is equals to tan y, tan y. See, so this is inverse trigonometric ratio. When you brought this to LHS, now this becomes what? Trigonometric ratio, trigonometric ratio. Again, whenever you shift either trigonometric or inverse trigonometric functions, so inverse trigonometric ratio becomes trigonometric and trigonometric becomes inverse trigonometric function. You should remember this. And then we have principal value branch for all inverse trigonometric functions. Okay, so that is we have range and domain. Here we have principal value branch. So here we have sin inverse x function. Sin inverse x function. For the sin inverse function, we have a domain minus 1 to 1, that is closed intervals. Range we have minus pi by 2 to pi by 2. That is, what is pi by 2? That is minus 92 plus 90. Minus 92 plus 90. Again, so we have cos inverse x. For this, we have a domain minus 1 to 1 and the range 0 to pi. That is 0 to 180. 0 to 180. So, in terms of radians, and this is in terms of degrees. Okay. Next, we have a tan inverse of x. So, r, that is real numbers. The range is minus pi by 2 to pi by 2. So, there is a difference between this and this. This is so closed intervals and this is open intervals. Open intervals. Next, we have cot inverse of x, r. Then, the range is 0 to pi. Then we have secant inverse x. So, here r except minus 1 to 1. The range 0 to pi except pi by 2. Then cosecant inverse x, r except minus 1 to 1 and the range pi minus pi by 2 to pi by 2 except set 0, except set 0. So, these are the principal value branches for sin inverse x, cos inverse x, tan inverse x and so on. You should remember this. So, whenever we solve any problems, you should look into the range of all these functions, okay. So, he may ask one more question from this content or this concept. For example, write the principal value branch of sin inverse x. You must write both the domain as well as range. Or you may ask, write the range of tan inverse of x, that is open interval minus pi by 2 to pi by 2. Okay, you should remember this. Next, we have properties of inverse trigonometric functions. First, we have, so that is sin inverse of sin x is equal to x, cos inverse of cos x is equal to x, tan inverse of tan x is equal to x, cot inverse of cot x is equal to x, secant inverse of secant x is equal to x, and the cosecant inverse of cosecant x is equal to x. That means here sin inverse, sin cancels. What is the remaining value? We have x. We will prove this one by one. First, we have, that is sin inverse of sin x. Sin inverse of sin x is equal to x. Here, to prove such a properties, just substitute for value which is within the bracket. Dear students, ಇಲ್ಲಿ bracket ಅಲ್ಲಿ ಯಾವ term ಇರುತ್ತೋ ಅದಕ್ಕೆ substitution ಕೊಟ್ಕೋಬೇಕು. So, put sin x is equals to theta. Sin x is equals to theta. Therefore, what is x? X is equal to, bring this sign to RHS. Now, this becomes what? Inverse trigonometric. Therefore, sin inverse of theta. Again, x is equal to sin inverse of, what is the theta value? Again, we have, that is sin x. Sin x. See, therefore, sin inverse of sin x is equal to x. Therefore, that is sin inverse of sin x is equal to x. Okay. Again, we have second one, that is cos inverse of cos x is equals to x. Same method, put, that is cos x is equals to theta. Therefore, what is x? X is equal to cos inverse of theta. Remember once again, whenever you shift any trigonometric ratio from LHS to RHS or RHS to LHS, trigonometric becomes inverse trigonometric. Therefore, so that is x is equal to cos inverse of theta. Again, therefore x is equals to cos inverse of, what is theta value? We have here, that is cos x, cos x. Therefore, that is writing the order, cos inverse of cos x is equals to x, is equals to x. Similarly, next one we have tan inverse, that is tan inverse of tan x, tan x is equals to x, is equals to x. So here same, that is put tan inverse, put tan x is equals to theta, tan x is equals to theta. Therefore, what is x? X is equals to tan inverse, x is equals to tan inverse of theta, x is equals to tan inverse of theta. But what is the value of theta? We have tan x. Therefore, that is x is equals to tan inverse of theta value, that is tan x, tan x. Therefore, tan inverse of tan x is equal to x, that is therefore tan inverse of tan x is equals to x. Next one we have cot, so that is cot inverse of cot x is equals to x, that is cot inverse, cot get cancelled, remaining value is x. So once again put cot x is equals to theta. What is x? X is equals to cot inverse of theta. Again x is equals to cot inverse of theta value, that is cot theta, sorry, cot x. Therefore, so that is cot inverse of cot x is equals to x, hence proved. Okay, the children, very simple. ಪ್ರಾಪರ್ಟೀಸ್ ಕೊಟ್ಟಾಗ ಬ್ರ್ಯಾಕೆಟಲ್ಲಿ ಯಾವ ಟರ್ಮ್ ಇರುತ್ತೋ ಆ ಟರ್ಮ್ಗೆ ಸಬ್ಸ್ಟಿಟ್ಯೂಷನ್ ಕೊಟ್ಟು ಗೋ ಫಾರ್ ಸಿಂಪ್ಲಿಫಿಕೇಶನ್, ಯು ವಿಲ್ ಗೆಟ್ ದ ರಿಸಲ್ಟ್ಸ್. ಅಗೈನ್ ವಿ ಹ್ಯಾವ್ ಅದರ್ ಟು, ದಟ್ ಈಸ್ ಸೆಕೆಂಡ್ ಇನ್ವರ್ಸ್ ಆಫ್ ಸೆಕೆಂಡ್ ಎಕ್ಸ್ ಇಸ್ ಈಕ್ವಲ್ ಟು ಸೈನ್ ಎಕ್ಸ್, cosecant inverse of cosecant x is equals to x. Just by using similar method, try yourself at home. Okay children, again, so sin inverse of sin x is equal to x, cos inverse of cos x is equal to x. Similarly, we have secant inverse of secant x is equal to x. Try this to at home. Okay. Next, second property we have sin of sin inverse x is equal to x, cos of cos inverse x is equal to x, tan of tan inverse x is equal to x, cot of cot inverse x is equals to x, secant of secant inverse is equals to x, cosecant of cosecant inverse x is equal to x. Okay. Similarly, we will prove one by one. First one we have that is sin of sin inverse x is equal to x. Here sin and sin not get cancels, we have x only. So here also I have already told you that substitute for what? The term which is in brackets. So therefore put that is sin inverse x is equals to theta. So this is inverse trigonometric function. So bring this sin inverse to RHS, therefore it becomes trigonometric. Therefore that is x is equal to sin theta, x is equals to sin theta. Again, therefore x is equals to, that is sin, what is theta value? We have sin inverse of x, that is sin inverse x. Therefore sin of sin inverse x is equal to x. Okay. Next, similarly we have second one, that is cos of cos inverse x, cos of cos inverse x is equals to x. So go for substitution, that is put cos inverse x is equals to theta. Therefore what is x? X is equals to cos theta. ನಾನು ಆಗಲೇ ಹೇಳಿದ್ದೆ, ಯಾವುದೇ ಒಂದು ಇನ್ವರ್ಸ್ ಟ್ರಿಗೊನೋಮೆಟ್ರಿಕ್ ರೇಷಿಯೋನ ಎಲ್ ಎಚ್ ಎಸ್ ಇಂದ ಆರ್ ಎಚ್ ಎಸ್ಗೆ, ಆರ್ ಎಚ್ ಎಸ್ ಇಂದ ಎಲ್ ಎಚ್ ಎಸ್ಗೆ ಟ್ರಾನ್ಸ್ಫರ್ ಮಾಡಿದಾಗ ಸೊ trigonometric becomes inverse trigonometric, inverse trigonometric becomes trigonometric. Therefore this is inverse trigonometric. Now this becomes what? Trigonometric. Again that is x is equals to cos, what is the value of theta? We have here, that is cos inverse of x. Again therefore cos inverse x is equal to x. Similarly, next one we have a third one, that is tan of tan inverse x is equals to x. Substitution, that is put tan inverse of x is equals to theta. Therefore, what is x? X is equals to tan theta. X is equals to tan theta. Now, substituting the value of theta, therefore, that is x is equals to tan inverse of x. Okay. Therefore, tan inverse x is equals to x. Similarly, fourth one we have, that is cot inverse x is equals to x. Put, that is cot inverse x is equals to theta. Therefore, what is x? X is equals to cot theta. X is equals to cot theta. Again, x is equals to cot of theta value. So, that is cot inverse of x. Therefore, cot inverse x is equal to x. Okay, dear children, in the similar way, just try the secant of secant inverse x is equal to x, and cosecant of cosecant inverse x is equals to x at home. Try this too at home by using the same method, Next property, that is third property, we have sin inverse x is equals to cosecant inverse 1 by x. Cos inverse of x is equals to secant inverse of 1 by x. Again, tan inverse of x is equals to cot inverse of 1 by x. Okay. Again, sin inverse of x is equals to cosecant inverse of 1 by x. Cos inverse of x is equals to secant inverse of 1 by x. And tan inverse of x is equals to cot inverse of 1 by x value. Okay. So, we will prove one by one. Okay. First one we have, that is sin inverse x is equal to cosecant inverse of 1 by x. Cosecant inverse of 1 by x. So, put, that is sin inverse of x is equals to theta. So, what is x? Therefore, x is equals to sin theta. X is equals to sin theta. Taking reciprocals on both sides. Therefore, that is 1 divided by x is equals to 1 divided by sin theta. 1 divided by sin theta. Again, so that is 1 divided by x is equal to, we know what is 1 by sin theta? We have cosecant theta. So, therefore, that is cosecant theta. Okay. So, now bring the cosecant to LHS. Therefore, that is cosecant inverse of 1 by x is equals to theta. But what is the value of theta? We have sin inverse of x. Okay. Therefore, that is cosecant inverse of 1 by x is equals to, we have that is sin inverse of x. Therefore, sin inverse of x is equals to cosecant inverse of 1 by x. So, similarly, this can be written as, that is sin inverse of 1 by x is equal to cosecant inverse of x, or cosecant inverse of x can be written as what? Sin inverse of 1 by x. For example, that is sin inverse of 5. Sin inverse of 5 can be written as cosecant inverse of 1 divided by 5. Again, it is in the form of sin inverse x. We know that sin inverse x can be written as what? Cosecant inverse of 1 by x. Similarly, sin inverse of 5 can be written as cosecant inverse of 1 by 5. Right? Next property we have second one, that is cos inverse of x is equals to secant inverse of 1 by x. Secant inverse of 1 by x. So, put that is cos inverse of x is equals to theta. Therefore what is x? X is equals to, we have cos theta, x is equals to cos theta, right? Again taking reciprocals on both sides, so that is 1 by x is equals to 1 divided by, we have cos theta. Again so that is 1 by x is equals to, we know that what is 1 by cos theta, that is secant theta. So secant theta. Again now bring the secant to LHS. Therefore secant inverse of 1 by x is equals to theta, is equals to theta. Again, but what is the value of theta? So we have cos inverse of x. Therefore that is secant inverse of 1 by x is equals to cos inverse of x, cos inverse of x. So this can also be written as, that is cos inverse of 1 by x is equals to secant inverse of x, secant inverse of x. Okay, again example, so we have cos inverse of 1 by 5, cos inverse of 1 by 5. Now this can be written as what? That is secant inverse of 5, secant inverse of 5. Okay, next one we have that is tan inverse. Tan inverse of x is equal to, we have cot inverse of 1 by x, cot inverse of 1 by x. Again put, that is tan inverse of x is equals to theta. Okay, again therefore what is x? X is equals to tan theta, x is equals to tan theta. Again taking reciprocals on both sides, that is 1 divided by x is equals to 1 divided by tan theta, 1 divided by tan theta. Again 1 by x is equals, we know that 1 by tan theta is cot theta. Bring the cot to LHS. Therefore cot inverse of 1 by x is equals to theta. But what is theta value? We have tan inverse x. Therefore that is cot inverse of 1 by x is equals to tan inverse of x. Again this can also be written as, that is tan inverse of 1 by x is equals to cot inverse of x, cot inverse of x. Again for example, so cot inverse of 1 by 2, cot inverse of 1 by 2 can also be written as tan inverse 2, tan inverse of 2, right? Remember this. So again example, cot inverse of 1 by 2 can also be written as what? Tan inverse 2, tan inverse 2. Okay, so again we have three properties. So that is sin inverse of x is equal to cosecant inverse of 1 by x, cos inverse of x is equals to secant inverse of 1 by x, 1 by x. Similarly tan inverse of x is equal to cot inverse of 1 divided by x value. So you should remember these properties as well. Okay, next the fourth property we have sin inverse of minus x is equal to minus sin inverse of x. Tan inverse of minus x is equal to minus tan inverse of x. Cosecant inverse of minus x is equals to minus cosecant inverse of x. Okay, again remember the sin inverse of minus x is equals to minus sin inverse of x. Next one you have tan inverse of minus x is equal to minus tan inverse of x, and then cosecant inverse of minus x is equal to minus cosecant inverse x. Again we will prove one by one. First we have first one, that is sin inverse of minus x is equal to minus sin inverse of x. Again put, that is sin inverse of minus x is equals to theta. So therefore what is minus x? Minus x is equal to sin theta, sin theta. So pre-multiply or multiply by minus. Therefore, that is x is equal to minus sine theta. Again, x is equals to sine of minus theta. So that is sine of minus theta can be written as minus sine theta. Okay, already was learnt in first POC. So again we have that is now bring the sine to again LHS. Therefore, that is sine inverse x is equals to minus theta, minus theta. But what is the value of theta? Here we have sine inverse of minus x. Therefore, that is sine inverse of x is equals to minus sine inverse of minus x. Again, so multiply by minus. Therefore, that is minus sine inverse of x is equal to sine inverse of minus x. So therefore, that is sine inverse of minus x is equals to minus sine inverse x. You should remember this. That is sine inverse of minus is equals to minus sine inverse of x. In simple way, sine inverse function ge minus comes outside. Okay. Next, similarly we have second one, that is tan inverse. So tan inverse of minus x, tan inverse of minus x is equals to minus tan inverse x, tan inverse x. Okay, always for real numbers. Again, therefore put tan inverse of minus x is equals to theta. What is minus x? Minus x is equals to tan theta. So inverse becomes trigonometric. Again, multiply by minus. Therefore, x is equals to minus tan theta. X is equals to minus tan theta. Again, so therefore that is x is equals to tan of minus theta. Tan of minus theta. Again, bring this tan to LHS. Therefore, that is tan inverse x is equals to minus theta. But what is the theta value? We have tan inverse of minus x. Okay. Therefore, that is tan inverse of x is equals to minus tan inverse of minus x. Again, multiply by minus. Therefore, that is minus tan inverse x minus tan inverse x is equals to tan inverse of minus x. Therefore, that is tan inverse of minus x is equals to tan inverse of x. Okay, we should remember. For example, that is sine inverse of minus 1 by 2. Sine inverse of minus 1 by 2. It is in the form of sine inverse of minus x. So it is in the form of sine inverse of minus x. What is x value here? We have minus 1 by 2. Minus 1 by, okay, sorry, 1 by 2. Okay. Therefore, this can be written as what? Minus, that is sine inverse of 1 by 2. Sine inverse of 1 by 2. Again, dear children. So it is in the form of sine inverse of minus x. Here, what is the value of x? That is 1 by 2. We know that. So sine inverse of minus x can be written as what? Minus sine inverse of x. Minus sine inverse of x value. Similarly, so that is again. So tan inverse of minus 2 can be written as minus tan inverse of 2, because now so this is in the form of tan inverse of minus x. We know that tan inverse of minus x can be written as what? Minus tan inverse x. See here, what is the value of x? 2. Therefore, tan inverse of minus 2 can be written as minus tan inverse of 2. Okay. So next property we have, that is cosecant inverse of minus x is equals to minus cosecant inverse x. Children, will you try this at home? Try. Use similar method. Put so cosecant inverse of minus x is equals to theta. Then go for simplification. you will get the answer. Okay, again try this at home. Okay, the children's, so remaining properties will continue in the next session. Thank you, ma.